successful.
OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Redline monitor, verify redline monitor and event table are in the correct configuration for terminal count.
Verified.
RC, verify solar radiation acceptable for launch.
Verified.
L minus 9 minutes.
Before we poll the team, let's watch a quick message from Leanne Corrett, President and CEO of Boeing Defense, Space, and Security.
To everyone supporting today's historic launch of the X-37B, thank you. On behalf of the entire Boeing company, I want to express my appreciation for your work to achieve this critical mission. Since the X-37B's launch in 2010, it has shattered all expectations. Every time it launches into space, it achieves firsts. And there is no other program that provides our nation an unrivaled capability to rapidly test and integrate new space technologies. None of these achievements would have been possible without your hard work and dedication. Good luck today. Thank you for everything you do. Stay safe and be well. Go Atlas, go Centaur, go SF-7, and go X-37B.
All steps are complete prior to the status check.
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the countdown. 29 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, in the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling of the launch team.
L minus 7 minutes.
Status check to proceed with terminal count, Atlas systems, propulsion. Go. Hydraulics.
Go.
Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Hazgas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
TCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilical.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. ALC. Verify T0 is set for 1314 Zulu.
Verified.
Polling is complete and the ULA launch team and the Space Force's mission director are go for launch. From T-minus 4 minutes until launch, you will be listening to Dylan Rice and his team performing the final steps in the countdown procedure. You will hear the team call out that Atlas liquid oxygen topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute and 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. At T-minus 1 minute and 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and USSF-7 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear Rob Kesselman providing launch vehicle ascent data.
L minus 4 minutes 30 seconds.
SMD, transfer spacecraft to internal power.
Roger.
All steps complete prior to terminal count.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
Mark. The time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 3 minutes, 55 seconds.
The countdown clock has resumed and we are go for launch at 9:14 a.m. Eastern.
T-minus 3 minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
T-minus 2 minutes, 50 seconds.
Spacecraft on internal power.
Roger.
FCS internal.
T-minus 1 minute, 59 seconds.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
T-minus 1 minute, 40 seconds.
Launch enabled.
137.
FCS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute, 20 seconds.
OCU's armed.
FCS count started.
115.
Reduce ECS for launch.
Roger.
110.
Vent valves locked.
T-minus 1 minute.
Rock, report range status.
Range green.
T-minus 40 seconds.
Stable at step 3.
Seconds. 25.
ECS reduced for launch.
Status check.
Go Atlas.
Go Centaur.
Go Space Force 7.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket with USSF-7 for the United States Space Force on a mission dedicated to America Strong.
Good. RD-180 has gone to closed-loop propellant utilization control.
You are hearing the voice of Rob Kesselman providing launch vehicle ascent data.
The pitch yaw roll program. Vehicle body rates look good. 35 seconds into flight. Atlas is now just under 1 mile in altitude, traveling at 900 miles per hour. Engine pump speeds and injector pressures are in family for this thrust level. The vehicle has now completed the pitch yaw roll program. Now 70 seconds into flight. Atlas is now 4 miles in altitude, 0.4 miles downrange distance, traveling at 1,200 miles per hour. Vehicle has passed Mach 1. Vehicle is now passing through maximum dynamic pressure, max Q. RD-180 is now throttling down slightly as commanded. Pump speed response looks good. Now 115 seconds into flight. We're now 14 miles in altitude, 5.6 miles downrange distance, traveling at 2,000 miles per hour. Vehicle has now begun closed-loop steering. The vehicle is now half the weight it was at liftoff, burning propellant at a rate of more than 2,600 pounds per second. Approximately 2 minutes remaining in the Atlas booster phase of flight. Sensor reaction system is now pressurizing flight levels. Atlas is now throttling to maintain 2.5 G acceleration limit. Now 180 seconds into flight. Vehicle is 44 miles in altitude, 40 miles downrange distance, traveling at 4,500 miles per hour. Approximately 1 minute to BECO. Standing by for payload fairing jettison. With indication of payload fairing jettison. And Sensor forward load reactor has also jettisoned successfully. Atlas is now throttling up to a 4.6 G acceleration limit. Centaur has begun the boost phase chill down sequence. Atlas is now at 4.6 Gs and maintaining that acceleration limit. EU has gone to closed loop control. Boost phase chill down is complete. We have BECO, booster engine cutoff. Standing by for stage separation. Stage set, we have successful stage separation. Restart on the RL-10. We have ignition, MES 1. Centaur has now begun the first of 2 RL-10 burns in today's mission.
Recently, I had a chance to speak with Boeing's Jim Chilton about the X-37B. Jim was over in Boeing's Mission Control Center at the Kennedy Space Center. Let's take a look. Thanks for joining me, Jim. As you know, this is a special launch dedicated to first responders. Would you like to address that to kick us off?
Hi, Tyler. Thanks for having me. And by the way, thanks for getting another great Atlas V to the launch pad to give us a ride. I would like to respond that in these challenging times, it's never been more clear the importance of first responders to our whole society. I'd also like to add a thanks to the women and men in uniform, because our U.S. defense posture hasn't changed and they haven't backed off a bit either.
In the context of this being a classified program, what can you share with us about what the X-37B is and does?
Well, X-37B is a really interesting machine. It's a reusable spacecraft. It is autonomous. It flies without crew. It can be rapidly reconfigured to host a wide variety of experiments, and it can take off from standard launch pads in standard rockets under fairings, and it can land autonomously through public airspace. You add all that up, there's a lot of innovation in this machine.
This is the 6th mission for the X-37B orbital test vehicle. Can you tell us a little bit about the history of the program?
History of the program is that Boeing developed this as a system for the U.S. Air Force, and it's flown 5 times. Each flight has been successively longer, setting a record for duration. The last flight was 780 days, start to finish, which is a long time in space. If you add up all the missions, just under 8 years in orbit and 1 billion miles. So a lot of traveling by this machine. It's hosted a wide variety of experiments and kind of advanced the state of the art in both reusable vehicles and the experiments she can host.
Tell us some of the unique firsts for this mission.
This mission is really interesting in that it's the first time we've flown a service module. And the service module extends the vehicle capability. We can host more payloads that way. So this is the most we've ever carried on an X-37B mission. One of the things we're carrying on that service module, which can release independent satellites, is a satellite designed and built by the cadets at the U.S. Air Force Academy. So they've built it, we'll release it, and they'll get a lot of learning out of that and a lot of science. There's a couple other things I find real interesting on this one. The Naval Research Lab has an experiment to turn solar energy into RF energy that can be beamed to Earth. Very early research kind of project, but long-term great potential. Very exciting and kind of thing this machine was built to do. And even NASA, this machine is a great blend of defense and research. NASA has a seed experiment on this flight. And the idea is they've collected a lot of data on the space station around radiation effects on seeds. Long-term human trips would require some agriculture. X-37B can go some places the station doesn't go, collect different kind of radiation, and our payload bay can be a different kind of shielding. So they'll get more data to complete their set.
Some might say the X-37B looks similar to a space shuttle. What are some of those similarities and differences?
Well, a similarity is the shape. You could say that the X-37B stands on the shoulders of the space shuttle. It is a winged re-entry vehicle. It's about a quarter, 25% scale of a space shuttle. An interesting fact a lot of people don't know is we modified the orbiter processing facilities. The actual hangars the space shuttles flew in and out of are the homes of the X-37B. So that, that's pretty interesting, from a common shape to a common home in the hangar. Differences, the X-37B is autonomous. The X-37B is more rapidly reconfigurable. And, frankly, the challenge of coming down through the public airspace without crew has been overcome and proven to work well. Also, the difference is the duration X-37B can fly. Our last mission was 780 days, and that's just a lot longer than a shuttle could stay aloft.
What have you learned in the past 5 missions that could be applied to the industry moving forward?
I would say the learning on X-37B over the last 5 missions is that we can advance the whole space ecosystem with rapid learning. Perfect for the U.S. Space Force. If you think about our ability to put small or large payloads into this vehicle, test them, and then bring them home and find out how they worked, that's really beneficial. The benefit is you don't have to commit to a large single satellite with its own launch or a constellation of satellites to know if something works. The benefits can be improving high technology. The benefits can also be improving, if you want to try to go with a lower reliability design, for instance, to prove that small sats could do missions traditionally done by other space vehicles. So the flexibility this offers the U.S. Space Force to advance the whole ecosystem, all of industry and all the government research labs, is terrific.
So Jim, anything you'd like to add in closing?
I'd like to add a big thanks to the U.S. Space Force, along with a congratulations. My personal appreciation for the Air Force Rapid Capabilities Office, the partnership and frankly the leadership in helping us get to this mission. I'm very grateful for my partners at ULA and the terrific ride, another great Atlas V. And, a special thanks to the Boeing team that worked very hard to make this mission come off. We're already here together because of you.
Thanks, Jim, for joining us today.
I appreciate it, Tyler. Thank you.
At the request of our customer, we'll conclude live coverage in a few minutes. But first, let's take a moment to remember those on the front lines of the battle with COVID-19.
Every day, essential workers and first responders on those front lines are providing hope and help to people in need. Their steadfast selflessness and sacrifice to their fellow citizens is a true testament to the foundation on which America was built. On behalf of the men and women of the United States Space Force, thank you for keeping America strong. We honor and celebrate your contributions to this great nation.
Hi, I'm John Shaw, Commander of U.S. Space Command's Combined Force Space Component Command and U.S. Space Force's Space Operations Command. As for many around the globe in this current pandemic, life at Vandenberg Air Force Base has changed significantly. But what hasn't changed is our spirit, our strength, and our teamwork as a joint and allied team. That endures. I can also proudly say that the 17,000 service members under my command around the globe are truly grateful for the healthcare workers, first responders, the military medical members, and the other essential personnel on the front lines around the world, keeping us safe in the face of this current pandemic. You are our heroes, and we're proud of all that you do. Stay strong and stay excellent.
Good morning, Colonel Jim Smith and Chief Boston Alexander from Schriever Air Force Base, Colorado. Here with a quick shout out and more importantly, a heartfelt thanks to our first responders and other medical professionals who've been on the front lines during this crisis.
In the face of uncertainty and volatility, thanks for standing in the gap, at times risking everything. We salute you.
Thank you to our healthcare professionals, to our military, and to our first responders who are helping to keep us safe during this global pandemic. I personally am humbled by your courage and your dedication in working through these difficult times. And I want to share that all of us here are inspired by your example and are continuing to do our part to help with national security and to make sure you have the space-based tools that help you do your job. We are America Strong, and together we will get through this crisis. Thank you.
From Vandenberg Air Force Base to all our healthcare professionals, first responders, and essential workers, we thank you. Every day, we see you dedicating time and energy to help prevent the spread of coronavirus. We see your efforts, we acknowledge the risks you are taking, and we salute you. You are truly our heroes. America Strong.
Thank you to all of our frontline healthcare workers and emergency personnel. There are no words to express the entire Boeing company's and my personal appreciation for your courage and dedication. You all are heroes. We are all forever indebted to you for taking care of those impacted by COVID-19 and for helping stop the spread of this pandemic. To our service men and women around the world who remain committed to their missions despite COVID-19, Boeing is proud and honored to stand alongside you. I also want to thank everyone supporting mission-critical activities like the launch of the X-37B. Thank you for everything you do every day. My very best to each of you, your families, and your friends. Please stay safe and be well.
Hi, I'm Colonel Rich Borkman, Vice Commander of the 460th Space Wing.
And I'm Chief Rob Duvall, Command Chief, 460th Space.
We want to thank each and every essential worker who keeps this country running, and those who are able to stay home to help flatten the COVID-19 curve.
Through your hard work and perseverance, we're able to maintain our mission of safeguarding America and our allies.
Thank you, and stay safe.
Viruses probably don't survive well in space, but down here on the planet, COVID-19 continues to impact our country. Americans are strong, and together we're resilient, and we will win this fight. No one exemplifies this strength more than the nation's frontline essential workers. As commander of the U.S. Space Force's Space and Missile Systems Center, headquartered at Los Angeles Air Force Base in California, and on behalf of our 5,000 personnel nationwide, thank you for your courageous and unwavering service to our nation. In these extraordinary times, you're not just heroes, your superheroes. From our healthcare workers, scientists, and first responders to the manufacturers